Thanks, Logan, for accommodating my need to go early. I appreciate that. Sharing my screen here now. Let me know. You guys see that all right?
Yep, looks good.
Okay. And you guys are looking at a notepad screen?
Yes.
Perfect. Okay. So what I'm going to talk about here this evening is basically machine learning in PL/SQL and Oracle Application Express. So PL/SQL stands for Procedural Language Extension to SQL. It's Oracle database's specific flavor of SQL that really allows users to be able to add functional components to standard SQL coding, like for loops, if statements, those kinds of structures, and really extend the capabilities of SQL into extra things. So one of the packages that they've built out within PL/SQL is this DBMS data mining package. And that really allows us to create machine learning models within PL/SQL. And so the really cool thing about that is that that really pairs in nicely with the just standard relational database technology. And then just as an extension of that, we'll talk about this in a minute or two here. But Oracle also puts out a product called Application Express, which is a low-code app development platform that allows users to directly tie into their Oracle database, but also have REST connectors and put in some HTML and CSS and some JavaScript to really customize out and build out web database applications. So that's a lot of what I do for my job. So I figured it's kind of a natural transition to kind of go over some of this stuff here today. It's not necessarily something that's super popular in this space. So it's something I think that most people have not heard of, or at least have not used very much before. So please just let me know if you have any questions at all. I don't have, I guess I can pull that up here. I don't really have the chat there. So either put them in the chat or just feel free to interrupt me as well. So I'll go through and walk through kind of what I did here to, just to kind of show you how these components all fit together. I used the HMEQ home equity data set that we're using in 422 and just piggybacked on the work that we're doing in Python and just kind of basically replicated it within PL/SQL here and using the DBMS data mining package to create this. So the first thing we do is this set of code right here basically is creating a model called HMEQ RF01. So it's a random forest model. We can set the algorithm name right here. We can put in a variety of parameters. I just put in the one parameter for number of trees that we're going to use. The mining function, so this is a classification model. Basically what we're doing here is trying to predict whether a particular person is going to default on their loan or not. So it's a classifier there. The query is just select star from a training data set. So I took the cleaned CSV file that we're working with in 422 and just uploaded that into a free Oracle database and separated that out with training and testing sets. And so this is the training table here. The set list here, this is the algorithm parameters. Case ID column name is basically the individual primary key record, and then what target is, and that target bad flag is basically what we're trying to predict. So using this little package here that is only a couple lines of code, we can train a model specifically on the training data set using the entire data set that we have listed into that table. So then what we do from there, we do a couple little apply and compute lift here. This is really helpful for tracking the performance of the model. And I'm not going to get into that a little bit because I think that would be beyond the 5 minutes that I have. But what we can do here is just using this script here, we can test the accuracy of the model. And basically that outputs to 91% accurate on the training and then 89% accurate on the testing. So basically what that ends up with here is I've created this form here that you can see. And basically what this does is it inserts a record into our standalone table that contains information as if it were a new record being added into that data set. I've then created a view, which is kind of almost a temporary table. It's basically a saved query that uses all of the appropriate information, stores that, and then also puts in the prediction using that HMEQ RFO1 model, and then the probability of that prediction happening and being correct. So that is what we will see in this page here. And so this is what Application Express looks like when you first spin it up. Done a couple things here. Again, this is a really nice tool because it's really quick to create. I probably created this page in about 5 minutes. And what this allows us to do is dump a couple pieces of information here, and with the click of an insert button, generate a prediction on the parameters that we put in here. So I'm going to put in the credit line here, and we're going to just say, let's say that's $24,000. The outstanding mortgage balance is, call that $39,500. Value of house, let's just say that is 65 to 40. Credit line age in months, maybe that's 89. Number of inquiries on the credit report, call it 32. Yeah, that's a little high. Let's call that 3 years on the job. Let's say they've been on the job for 8 years. There are 2 derogatory marks on their credit card or credit report. Let's go with 2 delinquencies. Number of credit lines, maybe 3. That's actually maybe a little low. Let's put that at 17. And debt to income ratio, we'll put that at a nice 28% or 28 ratio there. We'll say that this is for debt consolidation, and then this is for a person in the sales industry. I'm going to go ahead and hit insert here, and that'll spin out a new record here, which is this bottom one here. You'll recognize the, I guess it's this top one here. So we've determined then, I guess it's this guy's right here. We've determined that based on the parameters that we've put in and the model that we've trained, we're expecting this person will not default on their mortgage, and we're about 57% sure that that will be the case, that they will not default on that loan. And again, this has a whole bunch of applications from client facing to internal facing, but it's a really quick way of deploying a machine learning model to take in an input and then pretty much right away. And again, I built this in 15 minutes or so past the model training to spit out an output in a really digestible way. Anybody have any questions? Otherwise, I think I'm kind of running up on time here.
Yeah, Bennett, that was excellent. So do you have DBA experience in your background, I take it? I mean, because that looked exactly like somebody that's done a lot of SQL work in their lifetime.
I've spent the last year coding in PL SQL exclusively for my job. And so that's quite a bit of experience there. Not too much prior to that. Thankfully, this is really not all that difficult to learn. And I think it's actually a really nice tool that's underutilized in the industry, mostly because it's so specific to Oracle database. But like I said, it's actually shockingly easy to learn.
Yeah, you know, it's this is incredible. Really is. I was able to deploy that. I mean, I came from 7 years of Oracle experience, and there was always that little thing called Apex in there, but we never used it. So now I know what Apex is. So thank you for educating me. Shows how much I need to learn yet. But okay, I appreciate that. Feel free, anybody, once you get done presenting, if you don't mind going ahead and shooting me, any notes you have. Sometimes Don likes to give a few extra bonus points for that type of stuff too. So again, excellent job, Bennett. You really set the bar pretty high there. So thank you, sir.
Yeah, thank you.
Okay, the next one we have up here, Kieran. Kieran, are you here by chance?
I am. What a tough act to follow. I'm going to turn my camera on because I don't have a presentation. I'm just going to hope my face is enough.
All good.
Thank you, Bennett. That was a great presentation. I am at a loss because mine is nowhere near as technical, but hopefully still interesting. Today, I wanted to talk to everyone about freedom versus safety. I think, this is a huge conversation in America. Even in our legislation, you'll see the great American debate, freedom of religion, freedom of speech, freedom to carry. A lot of things about freedom are written into our laws. So it's very interesting to see how this debate is carrying over to the ever evolving industry of data science. And my hypothesis, given all the legislation we have in place, is Americans prefer freedom over safety. That being said, I'd like to dive into a little case study with everyone today. I'm coming back from Disneyland, so that's the inspiration behind it. We're going to talk about Disney and data. So Disney is like a conglomerate, right? There's a lot of different moving pieces. You have Disneyland, World, Plus, stores, merchandise, theatrical releases, Hulu, SPN, all of these various products that come out of this, what is kind of a monster of a business. Each one of them collecting data in a different way. For the purposes of this presentation, we're going to focus on Disney World. Disney World gets over 200 million people going to their park per year. I can't think in the millions, so I don't even know what that means. But in 2013, they introduced this new ticket entry into Disneyland, into Disney World, called the Magic Bands. Now, these are wristbands very similar to what you'll see at music festivals or, you know, sometimes various events that have RFID chips in them. What these chips do is they allow you to move through different security points, purchase items, and basically load all of the things you would need to move around an event like Disney World in a more seamless way than like pilfering through your bag for your different papers or whatever. So it's a very convenient and I would say effective manner of moving through Disney World, especially because it has increased traffic 30% since being released. How has it done that? Well, let's think about it. There are a couple of things that this wristband tracks. The first is movements, right? So when you're going on rides, when you're checking into your hotel room, when you're at the store. And the second is behavior, how long it's taking you to move from one ride to another. Which ride are you choosing after? When are you going to your hotel room? When are you going to go to a restaurant? Things like that. What are you going to purchase at the store? So by collecting this data, Disney is now able to do a number of things. A few of these things include making custom itineraries for your day because they know what you like about Disney because you've input all your personal information. They have a whole profile. So what rides to go on, where to eat, what attractions to see, what shows to watch. It also lets you link your account to all the photos of the rides. Everyone likes taking those pictures that they're on the roller coaster ride. Your hands are up. So it's a really easy way for the user to do that. Now that's just on the user side. On Disney's side, it allows them to see when too many people are congregated in one area. And so they can move traffic by pushing notifications to your Disney application on your phone. Hey, there's a promotion for this event. We know you like this event because we have your behavioral data. Why don't you move along this way? Or it allows them to open different lines of traffic like they did when I recently visited. When there were too many people in one area, they opened a secret door and let you go through the alley to decongest the area. So it increases the user experience at the park as well. It also tracks and can predict what your probably favorite Disney character is. And that informs costume changes, where the characters will appear. If you have the wristband on, the characters can even do a personalized, like, oh my gosh, how are you today, Logan? Who knew you liked, you know, Iron Man so much? So again, like a huge personal experience bonus, just because you put in your data here. In 2019, there was also a machine learning, I think, algorithm that they put in place using customer data, how many customers are going to use this ride. Weather data, we have this external weather source, whether or not that's accurate or valid, you know, we'll see. And then also just machine data on the ride itself to predict when will the ride break down and when do we need to order certain parts to make sure that we keep this moving as quickly as we can. Again, aiding in the customer experience. So with that said, you know, all of these data points are increasing the user experience of Disneyland without making them feel like they are being watched. However, the data is tracking all of your movements. So with that as our case study, you know, I think people prefer the facade of freedom with a personalized experience that is tracked by behavioral data. I say that with the caveat of if that is not used in the way to provide that personal experience to the individual, then there starts to be questions asked. That being said, You know, I don't know how many people are keeping their eyes on the various legislations that are passing the desks recently, but a lot of the hot topics are about data regulation. How are we protecting individual data? What does compliance look like for, sorry, that's my Slack. What does compliance look like for large corporations like Disney, like Netflix, like all of these large, you know, like Google? So I would encourage everyone to think about, how do we apply this learning that people actually like, the personalized experience, to the protection of data and legislation? And that is my presentation.
No, thanks, Kieran. Man, how did you know my favorite character was Iron Man there? I mean, if it's not him, then I don't know who it is, Thor or somebody.
It's
But
between Iron Man and Jack Sparrow for me. I gotta say.
oh man, that really hits a spot there. I mean, it was always for me growing up. It really was Jack Sparrow. I will admit that. Made my day there. Very interesting. In terms of security, surveillance, stuff like that, I think that's only going to become more a part of the public conversation here over the coming decades. You start talking about some of these bits of data and who really owns it. Who owns your data and what can they actually do with it? Within the legal confines. And I don't really know how that's going to end up shaking out. I think it's something we're going to deal with, probably potentially for the rest of our lives here. Just because if you're not even consenting to it, there's other ways companies can get your data, whether it be cameras out in public or whether there's other ways people are tracking your cell phone activity too. No matter what they do with Apple and things like that they try to do protect privacy, I don't think anything's a surefire solution at this point in the game. But thank you so much, Kieran, for giving this this presentation. Really is thought-provoking and hopefully gives everybody else here some things to think about and maybe look out for and read in the coming days and future here. So thank you. Okay, we're gonna go ahead and move on here to Deanna. Deanna, are you ready to present here?
Ready. Give me 1 second.
Take your time there.
Okay. So it's actually funny following up Kieran's presentation. Today I'm talking about anti-surveillance fashion. A lot of these projects have been conceptualized by artists globally, and this is more of an artistic commentary on privacy and the widespread usage of facial recognition technology. As we just discussed, this is gaining more popularity and more favor worldwide. So let's start at the beginning. In the 1960s, Woodrow Wilson Bledsoe automated facial recognition technology. There were also 2 other scientists that are credited with this discovery, but I couldn't find any way to corroborate that. So I'm just crediting this one person, but multiple scientists at IBM were credited there. In fast forward to 2010, Adam Harvey launched CB Dazzle, which is a concept art piece to evade facial recognition. And so you can see here some of the examples of like jewels and these particular, Adam Harvey has done so many interviews and he said that these particular concepts and art installations were highly effective at the beginning, but now as technology has kind of rapidly grown and has become more widespread, this early on attempt to evade facial recognition is probably no longer effective. In 2013, Simone Nikhil launched Real Face Glamouflage, which uses the faces of celebrities printed in these distorted shapes and patterns to trick facial recognition algorithms. And so you can kind of see here that this is Michael Jackson, and I think there's Barack Obama on there as well. This company is no longer producing. In 2014, there were 2 major contributions by Leo Salvaggio, who launched Your Me surveillance collective by printing his own face on masks and other wearables. I did not include a picture because it was really freaking creepy. And so you can take a look at that online if you're brave. And then Coop Himmelblau designed the jammer coat, which has this like pattern on it, which is supposed to prevent surveillance technology from recognizing the person who's wearing it in space. And this is a little bit of foreshadowing to something that I'll talk about at the end. In 2017, Jingkai Liu launched a concept called Anonymous, where you can see it's like this wearable technology that it's a projector that actually alters your face using light, and it's kind of like a holographic future dystopian kind of thing. That was really cool looking. In 2019, Kate Rose launched Adversarial Fashion, and you can actually obtain these shirts. They're in print, I checked. And it basically has a bunch of fake license plate numbers on the clothing that get picked up by surveillance cams, and basically inserts junk DNA into these surveillance systems. And going back to this kind of jammer coat, I recently, after I had already put together this presentation, I had read that University of Maryland CS department was successful in making what they call the invisibility cloak. And essentially what it is that it's a shirt printed with a bunch of faces, and they have proven that the surveillance technology does not pick up that there's a human there, even though it's clearly there. So all of this to say, whether you're for surveillance or not, this anti-surveillance fashion is kind of coming up, and the commentary around that is still very relevant. So thank you all for listening to my presentation.
No, thank you, Deanna. That's very interesting there as well. If you don't mind shooting that article over to myself and Dawn, I think we'd like to look at that a little bit further, and kind of just read a little bit more about that type of technology. It's out there. It's the first time I've heard of something like that as well. So kind of definitely is a nice little appetizer there to further study. So thank you. Okay, doke. Let me go ahead and see who's next here on the list. Give me 1 second. Okay, Shang is next. Are you still on here by chance?
Yes, I am.
Okay, yep, go ahead, sir.
Thank you. Hi, my name is Xiang Chen. I'm from 422. So tonight I want to just briefly show you all about this tool for mainly like non-technical people as introduction to data analytics and data science. So the tool is called KNIME Analytic Platform, and it's basically free to download and install on any platform of your preference. So in this case, I have it installed on my Windows machine here, but as I understand it, you can run on Mac as well as Linux. So what can you do with this particular tool? So to start with, it's not your traditional programming language. So everything, as you can see here, I have this example for credit scoring model. Everything is represented by these boxes. So in KNIME nomenclature, they call these nodes. So each node represents something. And if you go to configure, for example, this node is to read in a file. And in this particular case, it's just like reading in a CSV file from the web. And then, as you can see here, this is the data set that we're trying to like create some prediction on. So in this case is some German credit data. And we're trying to predict the score here based on this training data. So as I said, you know, you don't need to really like program anything in here. Everything is graphic based. So you can just drag and drop these boxes, and then you just have to like configure a couple of items to according to your use case, and then off you go, right? So let me just run this and you can see what it shows at the end. So to run this, you just need to click on like one of the end nodes here and say execute. And you can see that it will run everything here. So in this particular case, it's downloading the data, then processing it, like, you know, the usual of converting the nominal data to numerical data first as part of pre-processing, and then it will like run through different models like neural nets, SVM, and decision tree. And then it will select like the model that does the best in terms of accuracy. And at the end, it will save that model so you can deploy that like onto your production servers, right? So that's in essence what it does. And here we can see the graphical output of what it produced for the 3 models that was part of this particular use case. And we can see like the accuracy here in a bar chart when this finishes running. So it's gonna take a little bit of time here. As you can see, it's almost there, and it will show something like this, right? So in this particular case, we don't have a very good accuracy, but you know, looks like the SVM is the highest of the 3. So this model will like be the top chosen one for this case. But you know, this particular tool expands out to other use cases, and you can connect to like databases, and basically you can do like all your data science processing within this particular tool. Any questions? If not, then I'll hand it back to you, Logan.
Oh, thank you for showing that. Really interesting to see the KNIME platform there and how that runs. So thanks again for sharing that with us, Sean.
You're welcome.
Okay, we'll go ahead and keep rolling here a little bit. Okay, I'm just sorting out the list here again. And Andrew, are you available to go next, sir?
Definitely. Yeah.
Okay, fire away here. The floor is yours.
Awesome. Let me share my screen. I'm gonna go through just a quick kind of demo of Google's Collab notebook setup here. So Collab here is essentially a notebook style environment, interface, kind of like Jupyter notebooks or any other implementation of sort of notebook style coding. The big advantage, or the couple of big advantages that it has, is that it runs off of Google's hardware. So if there's, you know, a model that you want to run that is going to be particularly, you know, intensive on your computer, you can always, you know, try to run it on Google's hardware, right? And it's also collaborative as well. So if you have to, you know, really work with the team, then this is a good solution for having a collaborative space to all contribute code. So there's a couple of notebooks that I want to go through here. This first one is one that I wrote. I downloaded a data set from Kaggle. It's the Titanic data set, and I uploaded it into the directory that they give you here to work with. They also have some of their own just sample data in here, but I just wrote some code that if you run it, it will search for people on the Titanic who have a certain name. I just use my own here. And then we'll tell you sort of, you know, what was their survival rate, you know, were they on the lifeboats, right? Stuff like that. So just a sort of a proof of concept for me to sort of play around with what Collab has. But where I first sort of encountered this was there are different models and packages that you can use to sort of create AI generated art, right? And so I was investigating that probably a couple of months ago, and I was led to this notebook where they've really, you know, put the code in the background here. You can still see it if you want to, you know, click show code here. But if you just, you know, go up to runtime here, if you click, you know, run all cells here, it will it'll take in all of these parameters that you can set. The big thing here is right, it'll take a prompt to create art from whatever your prompt is, and then it'll start to iteratively, you know, build an image based on whatever that prompt is, right? So you can see this has been running for about an hour now, and it's on its 600th iteration. So this is something that probably couldn't run on my computer, but it's pretty cool to play around with it, and you can change a lot of these parameters. So it's I think this stuff's really cool, and it's great that it's running on a computer or on hardware that can kind of run it, and I can still use it. So I'll share this notebook if you guys want to play around with it. I would definitely suggest that. I think the prompt I used here was data science. So this is whatever this model is coming up with. I think it's trained on just a set of images that, like, millions of images that have been pulled from the internet. But yeah, I just wanted to go through sort of a quick demo of Google's sort of notebook environment here, Collab. So does anybody have any questions?
No, that's really cool there. I would just say you brought up a good benefit there of using some of the processing power there with Google Colab. Doesn't necessarily hit your own CPU or GPU unless you run a local runtime. So that's just one of those other nice benefits of some of these cloud computing type environments. So again, very interesting there. Is anybody have any questions here for Andrew before we move on? Okie doke. We'll go ahead and continue on here. Dinesh, are you ready to go here, sir?
Yep, I'm ready.
Okay, go ahead.
All right, let me share. All right, I wanted to spend some time today and talk about just some investing in the real estate market and the housing market, and talking about the 1% rule that's generally been the safe rule for what investors should look for. And I want to talk about maybe some breakaways from that and successful techniques that I've found. So generally speaking, the 1% rule in real estate investing is that if you're interested in buying a home and putting it up for rent, and that's sort of your long-term investment, a good strategy would be to purchase a home and make sure that you're able to collect 1% of it in monthly rent. So the example given here is if you purchase a home for $200,000, your rent should be $2,000 a month. That'll cover the 1%. That will also definitely cover your mortgage. And this is a great rule to have, but I think in modern real estate, this is a very difficult threshold to clear. And the reason it's giving the 1% is it expects you to pay off the house in 100 months or about 8.3 years, which, you know, seems like a dream. because I think the American dream is home ownership, not giving the bank a little bit of money just so you can live there. So here's another article that talks about the same thing. They give you a slightly different model, right? This shows you that, well, what if you have a $200,000 home? As long as you can cover your monthly mortgage, we can calculate it a different way, right? We can look at the property mean value, or the GRM, that shows you how many years you can pay it off. And so this shows you that, well, you could actually pay it off even quicker based on the rent. Once again, a very high bar to clear. So the very real example I can give you is in Fort Worth, Texas. Believe it or not, these are housing values for real homes. If you're living in big cities, especially the coast, you might be shocked. And these are new constructions too. I've limited this to 2018 and newer. So if we were to take this house as an example, let's see, where did it go? And this house here as an example for $269, I've opened it up here. What I'm recommending, and one technique that's worked for me, and I've used it for many years, and I'm working with an agent that's used it for many more years, is to say that to think about your estimated monthly payment. And the 1% rule says I should technically be getting $2,700 a month for this house. Nobody's going to pay that in the Texas market. I know in other places that would be reasonable, but to look at your estimated payment and say, are your estimated payments covered? As a rule of thumb in terms of what a good investment is. And it shouldn't just be 18, it should be a little bit more to cover incidental fees and maintenance. And when a person moves out, can you refurbish the unit to make it nice again? So obviously you don't want it to be directly on top of this, but ideally more. And that'll give you a starting baseline that is realistic in terms of a housing market. What Zillow's done, they've made it even easier. They've done the research down here, and they will tell you what they anticipate the rent market to be at the moment, right? So they've kind of shown you this. And from my experience, if you find the right property, you're able to cover not only the mortgage, but you're also able to cover agent fees. So for example, if you have a real estate company that's managing your property. So for example, I own a couple of properties, and I honestly can't tell you the address for one of them because that's how infrequently I've been there. The management company takes care of it. I get the rent check. And I get regular updates on tenants and things like that, but I will never meet the tenant never meets me. It's managed through a company. And so, it's a hands-off approach, and I'm still able to cover it despite not taking this traditional 1% rule that's over here. You can look through, and obviously you can pick different properties that make sense, but you're able to get new construction, standalone properties that aren't condos. And you can also say, I want a brick construction because in Texas, you have severe storms. And you can make, safer investments and whatever works for you. When I was practicing this, I think one question I got was talking about the mortgage rates. When you're an investor, traditionally your mortgage is different than if you're going to be living in that home. So you can estimate roughly 0.5% more in terms of your mortgage rate. That doesn't throw your numbers completely out of whack, but it's still a reasonable way to consider how you might launch an investment approach. All right, I will stop there because I promised myself I'd keep it under 5 minutes.
Excellent there. I had no idea what the Dallas-Fort Worth market looked like for housing, but it really gives perspective here to Northeast Ohio and Cleveland. I tell you, I thought we weren't as bad as some areas in the country, but my gosh, that seems so affordable down there. I'll be honest with you.
Yeah, one more thing I didn't mention is the additional payoff is once the housing market improves, and when you sell it, there's a capital gain there as well.
Yeah, very interesting. Well, thank you for sharing your knowledge in that, and hopefully, some other folks are able to find value in that as well, and I'm sure they did. So, thanks again. Okay, we'll go ahead and move on here and keep moving to Curtis. Curtis, are you ready to go?
How can I be of service?
Hey, yeah. Can folks see my screen? It should be some Google Slides.
Yep. Cool.
Yeah, so I wanted to chat with you all about experimentation. This program at Northwestern that we're all in is very focused on prediction. I think the program actually used to be called Predictive Analytics. And there are a few modules in a couple of the courses that cover experimentation and causal inference, but it's definitely not a focus of this program. And there's a whole other branch of data science, especially in tech companies and product analytics, that focuses on experimentation and causal inference. So I'd like to just give an extremely high overview. My goal is not to teach anything about causal inference techniques or how to run an experiment. That's not possible in 5 minutes, but I just want to try and demonstrate why I think you all should care about learning about this outside of the program. So experimentation and A/B testing, we've all probably heard about A/B testing. A/B testing, it's a randomized experimentation process to compare two versions of something to figure out which one performs better. Typically, we'll use like a t-test or chi-square test to evaluate the results. But these tests have some restrictive assumptions. So for example, to use a t-test to determine if the treatment caused some sort of impact, it's required that the treatment and control groups are basically equivalent or the same. So just as a ridiculous example, imagine testing a sprinting training regimen, and the regimen is watching TV and drinking beer all day. Usain Bolt is in your treatment group, and the control group is a bunch of average Joes. After the training regimen, we have Usain Bolt versus the average Joe. And after we do that sprint test, we find out that Usain Bolt is way faster using a t-test. So would we conclude that watching TV and drinking beer all day causes a faster sprinting time? No, because the treatment and control groups are not the same. And when the treatment and control groups are not the same, A/B testing and techniques like t-test and chi-square tests will not let you figure out causality. And so just a couple examples here of when A/B testing won't work. So the most common ones, A/B testing requires random selection into your A and B groups, and this is not always possible. It might cost too much money, it might be unethical, it might just take too much time for the company. Another one is confounding variables, also called omitted variable bias. Confounding variables makes it impossible to disentangle the effect of like X on Y. So you can't really infer anything about causality. We typically solve for confounding variables via randomization, but this can be an issue if your sample size is very small. So if we can't A/B test, what do we do? A/B testing is great, it's very common, it's a well understood method. But when we can't A/B test, what do we do? And so this is where econometrics comes in. Compared to machine learning, econometrics is much more focused on causality instead of predictive accuracy. Econometrics techniques can be applied to both experimental data, such as A/B testing, and observational non-randomized data. Of course, randomized controlled trials are the gold standard for determining causality, but it can be expensive, time-consuming, and/or impossible to do randomized controlled trials. So just as a personal anecdote, I'm actually not going to talk about these two examples I have on the slide. I'd like to give a different example that I've experienced myself. So the last company I worked at, I identified a very strong correlation between a particular variable and an increase in costs. So the higher this variable, the higher our company's costs. In order to make this variable lower, though, it'd be very expensive for the company. And because the relationship was just a correlation, there's no guarantee that spending the money to make this variable lower would lead to any reduced costs. And running an experiment would have been expensive as well. So I used econometrics techniques to show strong evidence of causation. And this led to my leadership authorizing the resources to conduct a small A/B test to prove whether this was a causal effect. And actually there was a causal effect. And so they spent the money to like improve that variable to reduce costs. So, and this is my last slide. I'm probably coming up on time here. So if we cannot A/B test, or if the data is such that we do not meet the assumptions to use common techniques like t-test or chi-square, what do we do? Well, here's 5 common econometrics techniques. It's impossible to explain each one in a limited time, so I listed 2 resources in the bottom left. I especially recommend the first link. I found it very accessible. I think anyone in this program who took 401 and 410, I think that's the supervised learning, like the class that covers linear regression. If you took those 2 classes, then you should be able to understand most of this first link here. And it's not a book, it's just like a short website. But I did want to cover one econometrics technique, and that's this first one, difference in differences, just to show you how cool these techniques can be. So if we look at this chart in the bottom right, let's say that the orange line is the treatment group and the teal is the control group. We can see that the orange treatment group is already performing better than the control group, right? The orange line is higher than the teal control group line. And let's say we're running a test and this graph represents the number of days a person goes running each month. So like, let's say we have a mobile app that tries to get people to run every day. when we have a treatment and control group where the treatment group already goes running more days than the control group. Critically though, the trends between these two groups are the same, right? The lines are parallel. They're both running more days at the same rate. So both the treatment and control groups are increasing the number of days they run per month at the same rate. And we implement a feature that we think will cause people to run more days per month. The vertical line, the black vertical line here indicates when we implemented this feature. And after this black vertical line, so basically after we implemented the feature, we see that the treatment group did indeed start running more, right? This purple line is like this is the treatment group now after the feature. They are starting to run a lot more. Now, if we just used a t-test to analyze the impact of this feature, and basically a t-test would just compare the means between the treatment and control group, we would see that the impact is the red line, the red circle. And this would be an overestimated impact. So this would show the treatment groups like at around almost 10 days running per month and the control groups at 6 days. So it's like this feature we implemented has caused the treatment group to run 4 more days per month than the control group. But that's not true, right? Because the treatment group is already running more. So a difference in difference technique would actually account for that. And it would give us the true impact, not this overestimated impact. So if you want to learn more about econometrics techniques, check out the 2 links on this slide. I'm graduating from this program soon. I've had 3 interviews so far. All 3 asked me more questions about experimentation and causal inference than machine learning. So I highly recommend you check out some of these resources.
Very insightful. Thank you, Curtis, for sharing that, and also giving some experiences of what you're seeing out there in the interview space when you're going to look at a new opportunity. So if anybody's looking at something similar here, it kind of gives you some tips on what to prepare for. So thank you again for sharing that, Curtis. Okay, we're going to go ahead and move on here to Michael. Michael, are you ready to present here, sir?
I think I'm the only Michael on the call. Yeah, I'm ready.
Oh, we have another Mike. We have a Mike Kaminsky here. So there you go. Okay.
Who is it Kaminsky or?
No, you're good. You're good.
Okay.
Yep.
Yeah, let me pull up my screen. All right. I'm going to do another quick presentation on some Google Colab notebooks that I've been using. I was going to present on virtual environments to use with Python, and my kind of motivation for that was that I think I had like some issues on my own computer with my Python installation, and I find myself turning to packages a lot when working on homework assignments and just projects on the side. And then at some point, I kind of lose track of all the packages I have and all the dependencies I have. And having tons and tons of packages just got really frustrating for me. So I was looking for something more concrete. And then I would run into issues with my Python installation, and then I would find some random resource on the internet that would, say would have the solution, and then I would get in the terminal and start doing some sudo commands, and then probably messing things up even more. So I decided not to do a presentation on virtual environments because I don't think I know enough about them. So instead, I'm going to talk about Google Colabs, and it's kind of a similar solution to a virtual environment in that the Python installation and the packages are mostly handled by Google. You can install other ones with pip and these things they call magic commands on your computer. And for me, at least, it's been a more seamless experience with Python. And then there's all the other benefits of the notebooks being saved on the cloud. You can go back to them in 6 months or 6 years, and they're still going to be there and work. But the part that I wanted to focus on today was these outputs that you can do straight from Collab to HTML, LaTeX, or even PDFs. And that's come in handy for me with all the homework assignments and turn-ins that we have for this class and a lot of other classes in the program. I kind of just touched on all of these things. The package maintenances can be tricky to try to handle on your own, virtual environments. And then specifically for this, the outputs of HTML or PDF, you can do both. I guess I can just get right into the code. So the package that I'm using is NB-convert. And this is a pretty popular package, I think, for going from a Jupyter notebook straight to a PDF or an HTML. It works really well with Jupyter, and it works pretty good with Collabs. Both Collabs and Jupyter notebooks are very similar environments. And let's see if I can find this. Yeah. So when you're the key is that you have to set your environment up to your Google Drive if you want it to output to your Google Drive. You can also set it up to your local environment, but I've just been doing everything on my Google Drive because I find it easier. So you can do that with these CD commands and then print working directory to make sure you're in the right drive that you want to be in. And then you can use this command here to install the LaTeX fonts required to go straight to a PDF. And I'd run through it, but it takes like 35 seconds to a minute. It's not that long. It's much shorter than it takes to install like a whole LaTeX engine on your local machine. And then once you do that, the command to print it to PDFs is pretty straightforward. I can just walk through. So that would be, you can select it to go to a LaTeX text document and then go in there and edit yourself, or you can go straight to a PDF, which I think is easier, but there are things that are a little weird when you go this way. But the output is usually pretty clean. All right, so here's the PDF that I just printed, and this is a pretty nice output, I think, to go right from a Jupyter notebook to something that, this is all just like fake text, filler text that looks pretty professional. You can have your equations numbered, your graphs will show up centered. I didn't really put any titles in here. These graphs are just straight off the Seaborn website for examples. And then your headers are automatically numbered and page numbers and other typical benefits that come with LaTeX. And then just to also show like the HTML output. Oh, wait, that's the actual HTML. Oh, here's the HTML. And then you can send it to an HTML and then print, but then some of the LaTeX stuff is a little bit different and your markup languages are going to vary a little bit. So I might be coming up on time here, but this is just something that I found useful and wanted to share with the class. Maybe you guys will find some use in it too. And it's really like a couple lines of code. So that's all I had. If there's any questions, or if not, I'll hand it back.
No, thank you, Mike. I appreciate you sharing that with us. If you don't mind shooting over that little file you got there, that would be helpful, I think, to Don and myself. And I could definitely see, this being useful for the class going forward, something similar to this when it comes time for people to turn in PDFs with their files. So maybe we can kind of steal some of this information from you here, if you don't mind, and look at potentially implementing as part of the class. I see this as being something that's very useful. So thank you again for sharing this.
No problem. I'll send it over.
Yeah, actually, would it be possible to plop a link in the Zoom chat too, just so I would love to take a look and learn from this.
Yeah, I'll drop it in there right now.
Thanks, Ben.
Yep.
Another excellent presentation. All these have been very good today so far. So thanks again, everyone. We'll go ahead and move forward here. Kevin, are you ready to present here?
Yeah, for sure. I can definitely present.
Okay, you got the floor, sir.
Excellent. And before we jump too far, Michael, I don't know if you've tried this before, but for managing environments, I've actually found Anaconda to be quite a bit better than using Python's built-in virtual environments. So
You know, it's funny you say that. I started with Anaconda, and then I hated how there was like 1,000 packages pre-installed. And so then I tried to install like a clean version and manage it myself. And I think I made it way worse. So now I have like 6 different installs of Python, and it's a disaster.
Yeah. So yeah,
should've
I
stuck with
typically just
Anaconda.
install. Yeah, I typically just install what's called Miniconda, which is just Anaconda with basically everything stripped out. And you can get that off their website. You just search for Miniconda instead. So
Great. Thanks, Kevin. I'll check that out.
yeah, for sure. Okay, I'm gonna go ahead and share my screen here. Let's see. We can see my presentation here.
Not yet. But it shows
Says
you started
you've
sharing.
started screen
There we
sharing.
go.
There it is.
Okay, it crashed for a second, so hopefully, let's see. Okay, trial number 3. We on?
Yep, looks good.
Yep.
Okay, trial 4. If maybe I'll just do without the, or just show portions of or something. I don't know why I'm having so many difficulties, but okay. So today I'm going to talk about neuroscience and machine learning, with the idea being that we often use artificial neural networks, and they are based loosely on neural networks, and figured we could talk a little bit about neuroscience. You know. So running from there, let's start with what is the basic computational unit for the brain, and that would be the neuron. Now there are a bunch of other cells that are involved in the brain, such as the glia are the most popular and noted, and then there are all sorts of additional cells involved in maintenance and things like that. But the neuron is the computational cell, and it breaks down into 3 major parts. There is the soma, which is the cell body, the dendrites, which are the pieces that receive information, and then the axons, which transmit information. And this image that I have on the left here, this is actually from a series of drawings done by a very well-known neuroscientist from the late 1800s named Ramon y Cajal, Santiago Ramon y Cajal. And he was basically the first person that proved that neurons existed. So in this image to the left, the big tree bits on the top are the dendrites, those pieces that receive the information. And then that's processed in a way inside of the soma. And then the information is transmitted down on those pieces that are labeled A and B, which are the axon. And the cell can actually be viewed a little bit as an analog to digital converter, because what happens is you'll get information coming in across all of these different dendrites together. And once it reaches a certain threshold of information coming from all of these different dendrites, then the cell will say, oh, it's time to activate. And it'll send a pulse of electricity down that axon, which is just going to be a binary 1 or 0, right? Because it's either going to pulse or it's not, right? And this can be viewed as quite similar to an artificial neural network with some logistic activation function. So from there, let's take a look at what we're actually doing when we're recording neurons, when we are doing any sort of in-lab actual neuroscience, right? And this is just one way that neurons are recorded, but this is with what's called extracellular electrophysiological recordings, okay? So extracellular meaning it's outside of the cell, so we're not doing any sort of puncturing the cell itself, and electrophysiological meaning the electricity here. So what you do is you record an extracellular voltage rather, and it's a really noisy signal that's going to have all sorts of spikes based off of movement and just heart rate and things like that. You're going to go through and you're going to filter those, and then you're going to end up with a signal that's based around 0 with these spikes off of it. And those spikes are actually when the neuron is firing, that axon is sending out that information. And you can go ahead and set a threshold on that, on the voltage value, which is what we're seeing here at left. We're looking at filtered and thresholded extracellular voltage. And you can go ahead and turn that into a firing rate. So basically saying, how often is this cell activating? And using fairly simplistic machine learning techniques. So in this case, I just used ridge regression. So just a linear filter with some L2 regularization and then a little bit of time shifting onto it. You can do predictions on what the body is doing very well. So these bottom 2 traces that I have here are force outputs from a manipulando while I was recording some the neuron firing rates. And you can see that I was getting a R2 score on these predictions of about 0.7. So the blue here is the actual force trace, and the orange is the predicted force trace. So that's really cool that we could do these very simplistic models that we learn in 422 and turn around and do a really surprisingly good prediction. So with that in mind, how does neuroscience inspire machine learning? Well, the most obvious one is just artificial neural networks in general. You've got these many different very simplistic processing units that are summing over a large number of inputs. And then once they turn around and get over a certain threshold, they turn around and tell their following layers, the following neurons, to go ahead and fire off. And that all gets summed up, like in this diagram to the right. Now, similar to a more complicated artificial neural network, a real neural network has lots of recurrencies. It's going to have multiple different types of connections. It's not just going to be like one on or off towards all of its following cells, but it's going to be, a bunch of other information. For anyone who's heard about neuromodulators, and those are going to change, the activity and the weights of that matrix, that neural network. And it has inspired certain types of neural networks that are used very popularly. For example, convolutional neural networks, which are used in visual processing a lot. They're very similar to how the actual visual system works. Your eyeballs and like the retina inside of your eyes, where the nerves or neurons are inside of your eye. And then a lot of the visual processing system does those same levels of like filtering that a convolutional neural network does. However, there are a lot of differences. So for example, when you're training a multi-layer neural network, artificial neural network, you've got backpropagation. But we are yet to identify a mechanism in the brain that could be anything like backpropagation. So that's one way that it diverges. Now, we're at the point now where it's not just neuroscience in inspiring machine learning, but really machine learning also can be used very heavily in neuroscience. So this figure on the left is from a former colleague of mine that's very cool. Basically, what we're doing is we're recording from a large number of neurons simultaneously. And then we use really fancy dimensionality techniques to get some sort of underlying encoding that the neural network is doing. These can be from the simple methods of dimensionality reduction, like principal component analysis. But you can also have very, very complicated ones that introduce all sorts of things like dynamics to the system, and no guarantees of like linearity or normality between the different vector spaces and whatnot. One very interesting technique to do that is what's called LFADS, which is based off of some really cool neural network stuff. And then another paper I read recently that I really liked that looks at neuroscience through a machine learning perspective is from Sun et al. In 2021. It was a bioRxiv publication. So I think it hasn't been peer reviewed yet. but it goes into like student and teacher networks and how that could be applied to how the brain learns. And if you're ever wanting to learn more about this sort of thing, there's a pretty cool podcast that goes into this called Brain Inspired, which brings on neuroscientists and machine learning and AI folks, and they chat and talk about their research. So, and
Wow,
hopefully,
thank you.
hopefully I didn't cut out too much. I hope folks actually got something from that. So.
No, thank you, Kevin. I appreciate that. Going into something like neuroscience here and explaining that, very high level, obviously very complicated. I'm in the medical field, so I found a little bit of, knowledge in that, something that maybe I want to research a little bit further. So thank you for your presentation today, sir.
Yeah, absolutely.
Okay, we're doing okay here on time. I promise not to keep folks here too much longer, so I'm going to go ahead and move on here next to Marco. Are you ready to present?
Yep, sure thing.
Okay, you got the floor. Thank you.
All right, sounds good. All right, can you guys see my screen?
Yep.
Awesome. So I'm gonna show you guys an example of web scraping using R. This was something that came up recently for me on a project that I'm working on at work, where we were hoping to get like a updated date to plug into an R Shiny app. And I didn't really know much about web scraping, or if you could use R or Python or whatever for that. So I got into that a bit, and I'll walk through a quick example of how to do so, because I found that pretty interesting. As someone in the past who, if I was trying to get data from a data table, it would just be copying and pasting, and that was kind of a pain for various reasons. So, so here's an example of something that just a random table on ESPN with some random NBA related indices, whatever you want to call them. This is their basketball power index, which just says or assigns a number to like how well a team is playing or how good they are, or whatever exactly you want to call it, which isn't really too important for this example, but this is just a quick table that I went straight to. So to get into the code a little bit, just a few lines of code here, a really simple example. Let's get the spoiler out of there, down there. Just have to read in this rvest package, which is a play on words for harvest. We're harvesting the information from the website. Just have to plug in the URL here. You then just read that that HTML from that URL, and you can do a variety of things from there that you want to pull out once you get to that web page. For me, like I was showing, I wanted to get stuff from a specific table. So I can show you kind of what you need to be able to do that. So this is something I knew literally nothing about before looking and finding this example online. But so you can highlight something, go to inspect, and then it will open the HTML. And then you can see based on what you highlight in the HTML, it obviously responds to, corresponds to a certain place on the page, which is interesting. Again, as someone who does not know how any of this works at all. So what you have to do to be able to pull out this table in particular, you really just find, the corresponding chunk here. You can copy that. You copy the XPath for that table, just to test it. I already have it in there, obviously, but just to test to make sure that I got the right thing. Yep, that should match in there. You just say XPath equals whatever. Probably some other parameters some other parameters arguments that you can pass here for other ways exactly to specify what you want to get here. But if you're going the XPath route, then you just paste that right in there. Just through that, assign that to BPI, and then let's go ahead and run it and see what we're looking at. So here you can see that table came right in. Was obviously much easier than copying and pasting, and all of that stuff just wouldn't really be what you're trying to do if you were more frequently relying on various web pages and updates and that type of thing. A lot more reproducible here, where you can just run this code and get, you know, whatever the updated information is that you're looking for here. It looks like this was updated just this morning. So so yeah, that's really the majority of the update here, of the presentation here. One quick note, I think that some websites probably don't love when you do this. There's a lot of websites out there that just have like a ton of statistics, and I think sometimes they have some disclaimers about like, you know, do not scrape our websites, do not write scripts that will, you know, constantly be pulling stuff from our websites and that type of stuff. So that's one minor consideration there, but just wanted to share this as something that came up in my work life recently that I knew nothing about, that, you know, was pretty cool from just previous years of manually copying and pasting and formatting and stuff that's just generally a pain if I wanted to get something from a table online. So hope you guys enjoyed.
No, thank you for sharing that, Marco. That's definitely a very useful tool. There's a lot of applications. I mean, I messed around with that maybe 2-3 years ago, back in 20, with RVest and a few other things, but my application was a little bit more, I'd say it's a different use case. I was actually looking at rating information. So I'll give a quick story here. I worked in logistics and transportation for FedEx back in the day before I switched to my current career in healthcare. And we used to set market rates for customers that would call us to move a full truckload shipment from point A to point B, and we'd have market pricing, and I was on the pricing analytics team. And our main competitors out there had web platforms as well, whether that be C.H. Robinson, XPO Logistics, Convoy. Uber Freight really wasn't a thing back in the day. And they had public websites where they didn't have to necessarily log into, and you could run, you know, rates from point A to point B with zip codes. And they would give you a rate on what our competitors were charging for given lanes. And so that was an effort that, you know, I undertook, you know, years back, and I can't remember which one actually got it to work for. Just writing a function to go ahead and put in different zip codes. And it was actually within the HTML, not the HTML, the URL string. And within the URL string, you could manipulate it enough that it would fill in the right, it would make the right call out to the website to give a rate. But over time, those stuff did change, and you weren't able to do that though. So that's the unfortunate thing. So very interesting. I'll go ahead and kick this off, I think, to our last person here to go, unless I'm missing somebody. But Spencer, have you had a chance to go yet? Because I know we got Mike here. We got everybody else that's on the call here has had an opportunity to go. But Spencer, can you hear me by chance? Okay, yeah, he's the only one that I haven't had a chance yet to go here within our group on our list, but maybe I'll send him a message here by chance real quick here, give him an opportunity. Okay. Good deal here. Okay, doke. Yeah, we're gonna go ahead and wrap it up here. I appreciate everybody hopping on. If you have any questions, feel free to reach out to me at any time. Dr. Wedding will go ahead and have, you know, your guys' points added here within the week usually. And really enjoyed everybody's presentation here, and see you guys in class. Don't be afraid to reach out. Thanks, everyone.
Thank you. Appreciate it.